On this example, we're told that our angle theta is between 0 and pi over 2, which basically means it's an acute angle, can be drawn in the first quadrant if we'd like. And we're also given that the tangent of theta is 3 over 5. What we're going to do here is we're tasked with finding the other 5 trigonometric ratios, so sine, cosine, cosecant, secant, and cotangent. What I like to do when I'm doing these is draw a quick triangle. It doesn't have to be super accurate. It just has to be a right triangle. We'll label the sides, and we'll identify which angle is going to be our theta. So I'm going to put it in the bottom left over here. My right angle is indicated with the box. From the very beginning, we can start labeling our sides. So our sides, based on SOHCAHTOA, because we're given tangent, we can say tangent is going to be opposite over adjacent. So we have 3 on this side, and the adjacent is going to be 5. And I'm also going to go ahead and label this is our opposite side, this is our adjacent side, and then here is our hypotenuse. That'll help as we're setting up these other trigonometric ratios. From the very beginning, we can go ahead and find cotangent, because cotangent is just tangent, but the reciprocal, so inverted. So you take numerator and denominator, and you have them switch places. So we can say this is 5 over 3. Now for each of these other ones, let's focus on sine and cosine. Sine is going to be opposite over hypotenuse. Cosine is going to be adjacent over hypotenuse, but right now we don't know what the hypotenuse is. So let's pull out the Pythagorean theorem, a squared plus b squared equals c squared, and we can use this whenever we have a right triangle. So let's fill in. The c is always the hypotenuse of our triangle. So we can fill in 3 squared plus 5 squared equals c squared. And with a little bit of solving down here, we can say this is 9 plus 25 equals c squared. So we have 34 equals c squared. Apply a square root to both sides. Don't need to worry about the positive and negative case in this one, because it's a side length on a triangle. That's really not going to be a negative. So this hypotenuse, we can put square root of 34. Now that we've indicated all the side lengths, the 2 side lengths and the hypotenuse here, we can go ahead and use SOHCAHTOA to help fill in for sine and cosine. So sine is going to be opposite 3 over the hypotenuse, square root of 34. And we could rationalize this by multiplying numerator and denominator by the square root of 34. This will give us 3 times the square root of 34 over 34. For the cosine, that's going to be the adjacent side, 5 over the hypotenuse, square root of 34. Again, if we want to rationalize this, it's a pretty simple task in this case. We're going to multiply numerator and denominator both by square root of 34. So we have 5 square root of 34 over 34. That'll be our cosine. To get cosecant, it's handy to remember that that is a reciprocal of sine. So we can take, I'm going to use the original version of sine where it was 3 over the square root of 34. We're going to invert this, and we have our cosecant. And to get secant, that's the reciprocal of cosine. So again, I'm using the original version, 5 over the square root of 34. Switching places between numerator and denominator using its reciprocal, and that'll give us the secant of theta. All right, hope this helps out. Get down the Pythagorean theorem. It's not that tough to memorize. Understand SOHCAHTOA. Draw yourself a triangle on each one of these. It's way easier if you label the sides, I feel. It's always helped me to just get a basic picture in front of me, even if it's not to scale. You can get through these. They're not that bad.